My fabulous chemistry minions, video number 4, recognizing acids and bases. Today we're going to kind of get into the properties and the characteristics of what an acid and a base are. Okay, so again, acids always produce H positive ions from their formulas. Both theories basically say that. One says it's an H plus donor. One says it produces just H plus as the only ion or positive ion in solution. Okay, these react with water to make H3O plus ions, hydronium ions. I think I've said this now in 3 of the 4 videos. I hope you're getting it as of right now. Acids are tart. Many foods that we eat have acids in them. Right off the bat, vinegar. Vinegar is acetic acid. Citric acid in your like lemon juice, orange juice, right? Lime juice all has citric acid in it. It stings when it's in your eyes or into cuts, like lemon juice. If you get it in a cut on your hand, it's going to sting. Okay. Here's the big one. Let's put a star next to this one. Reacts vigorously with metals to produce hydrogen gas, H2. We're going to use that later with table J to prove if something's acidic or not. Okay, they are electrolytes. Acids are electrolytes. They produce dissociated ions in solution, H pluses and whatever else is there. And by definition, they turn litmus paper red. We'll get into indicators later. Okay, they do also generally look like pure water. They're clear and colorless a lot of times. Bases have slightly different properties, not completely different, but some. So produce hydroxide ions, OH minuses in solution, either directly or indirectly. We can talk about both theories now for bases. Bases are bitter, so this is something that's like in like dark chocolate is slightly basic because it gets that bitter taste from a base inside there. It's also in soaps. They react with skin to produce a very slippery feel. Okay, bases are really slippery. If you get a little bleach on your hand, it gets really slippery. It's not quite slimy, but you know what I mean. It's very slippery. Soaps are very basic. It's part of how we clean oil and grease so well. They are very, they got a different, similar oil and base to them that your skin would have, or anything else you need to clean like that. There are also electrolytes. This is what they have in common with bases. They are electrolytes, so they do produce ions in solution, just different ions, and hence they turn litmus paper blue. Okay, they also can look like pure water, very clear and colorless. Although bases tend to sometimes have that little like ripple in it almost. If I make a like an ammonium or sodium hydroxide solution, a base solution, when I first make it, it'll have this weird ripple to it that an acid wouldn't have. Very much like it, the road, a hot road in the summertime, you see it kind of rippling with the heat. You can almost see that in the water. It's kind of cool. A base would do that, not an acid. They do not react with metals. So this is how I can differentiate them based on reactivity. If one starts bubbling, it's an acid, and if it doesn't, then it could be a base. Okay, and then salts. This again is a generic word for any ionic solid. Chemists call them salts. They are the product of any neutralization reaction, which is an acid plus a base. Second time we've talked about this so far, and we'll have a full video on just this topic. They do not produce H pluses in solution when they dissociate. So an ionic salt will not have H plus in it. It does also not produce OH minus. Okay, OH minuses would be bases. Neutral salts don't have those. So real quick, the naming structure. This is going to be part of the POGIL. You're going to figure some stuff out with how to name stuff. But here's all the answers to that part of the POGIL. The spectator ion is the root. We call the spectator ion a thing that's just there, not the H plus or not the OH minus. Okay, we call that the spectator ion. Spectating. And then we all ending with ic acid. So Cl minus is chlorine, hydrochloric acid. He's the only one that starts with hydro. But this one starts with nitrous. And this one starts with nitric. And sulfur, phosphoric, carbonic, coming from carbonate. Okay, so I use the root. So this one is the only one that kind of defies things. It has the hydro in it, HCl, hydrochlorine. Chlorine becomes chloric, and it becomes hydrochloric acid. It's the only one that has the H in the beginning in the hydro. So on the bases, we just name the metal, end with hydroxide, which is nice. It's just NaOH becomes sodium is the metal, OH hydroxide, we call that sodium hydroxide. We just name the base. And guess what? They're all in your reference tables. So those two reference tables are on page 6, right on top of each other right here. And generally the only acids and bases you'll be in charge of naming are these ones. So you can just look them up. It's no more complicated than that. And with that, we just cranked through video number 4.